Greetings! My name is Dr. Fuller. I would like to introduce you to the mathematical world around you. In statistics, we use many different calculations to understand a data set. Measures of variance tell us if the data is clumped together or spread out. A high variance means the data is spread out over a large range, while a low variance means the data is clumped together within a small range of values. One measure of variance is called the mean absolute deviation, or MAD. It tells us how much each data point varies from the average. The MAD is less sensitive to outliers than other measures of variance, making it a robust measure of variability for certain datasets. Mathematicians may not be the most creative with names, but that makes things straightforward in this case. The mean absolute deviation is calculated by taking the average, or the mean, of the absolute values of the deviations of each value from the mean. Yeah, that last sentence had a lot of math words in it. Let's break it down so it makes sense. Let's start with an example using whole numbers. Suppose you have 5 cats and you want to ensure that their weights are relatively stable. They weigh 8, 10, 12, 14, and 16 pounds. First, find the mean weight of the cats. Add up all of the weights, then divide by the number of cats, in this case 5. The sum of 60 divided by 5 leaves us with 12. The average, or mean weight, of the cats is 12 pounds. Next, we calculate the absolute value of the deviation of each cat's weight from the mean. Deviation means difference, so we subtract each weight from the average. However, we don't want negative values in our calculation. We want to know how far each value is away from the mean, not its direction. This is where absolute, or the absolute value, comes in. To do this, subtract each cat's weight from the mean and take the absolute value. Because we want a single number to represent the sample, we calculate the mean of these values, the mean absolute deviation. We are taking the mean of the absolute deviations. The mean absolute deviation is 2 4/10 pounds for this group of cats. Great! So, what does a MAD of 2.4 pounds mean? On average, each cat's weight is about 2 4/10 pounds from the mean. If we were to create one typical cat to represent this group, its weight would be around 2.4 pounds above or below the mean. That's to say, there's a good chance that the cat weighs about 9 6/10 pounds or 14 4/10 pounds. The MAD gives us an idea of the spread of cat weights around the mean. A MAD of 2 4/10 pounds indicates a moderate spread in the weights of the cats. If the MAD were lower, like 1 pound, the weights would be closer to the mean, showing less variability in the data. If the MAD were higher, like 5 pounds, the weights would be more spread out, indicating greater variability. In practical terms, knowing the MAD helps you understand the consistency of the data. You might want to know this value to understand if the cats are maintaining a consistent weight as a group. Additionally, the MAD can help you understand if some cats are significantly under or overweight. Using mean absolute deviation, you could also track a cat's weight over time. A low MAD would indicate that the cat's weight stayed consistent. The MAD of 2 4/10 pounds in our example indicates that the weights of the cats are reasonably close to the average weight, but there is still some variability. Most likely, there are no cats that are significantly under or overweight when compared to the others. Here is another example with a bit less explanation. You track the times of day the 5 cats ate. The times are as shown. On average, how far away from the mean dining time do the cats eat? Or, what is the mean absolute deviation? Step 1 is to calculate the mean. Step 2 is to calculate the absolute deviations from the mean. Step 3 is to find the mean of the deviations. The mean absolute deviation for the cat's dining time is 1 4/10 hours. This means that on average, the cats eat 1 4/10 hours, or 1 hour 24 minutes away from the mean feeding time of 6 p.m. The MAD in this case is relatively small. It shows some deviation, but nothing extreme like one cat eating in the morning. As a side note, sometimes it is helpful to convert times into 24-hour time. For example, 6 p.m. is the same as 1800. The MAD, or mean absolute deviation, shows the amount of variability in the dataset. A low MAD indicates that the values are close together and show little variability. A high MAD indicates that the values are spread apart and have greater variability. In my mathematical world, I have one little problem. Mean absolute deviation is an interesting subject. I spoke with several of my friends to understand how this statistical measure is helpful to them. Help me understand these situations. Mr. Jones said he uses the MAD to understand and demonstrate the consistency of a student's performance. Suppose student A had the following grades for the past 6 tests. How consistent are student A's test scores? Suppose student A was competing against her twin sister, whose MAD for the same tests was 2.5. Who is more consistent? How do you know? Christoph is a social media manager. He tracks the engagement metrics for a recent campaign. One post received the following number of likes, shares, and comments. How consistent was the campaign from the perspective of engagement? Kurt loves to play basketball and plays on a local recreational team. In the last 10 games, he scored the following number of points. Does the MAD show he was consistent? If his coach has a choice to put in Kurt or another player whose MAD is 5.7 points, which should he choose? Defend your answer. Moran grows field corn. He tracks the growth by sampling from different parts of his fields. The amount of growth for 5 plants was 78 inches, 80 inches, 81 inches, 83 inches, and 89 inches. Is all of the corn growing about the same, or are there large differences between the growth amounts? Max is an artist and does graphic design. Max tracks the amount of time to complete the last 5 projects. How consistent is Max? Why might someone who works on a variety of projects need to understand the mean absolute deviation of the times they spend? Kayla has a side gig delivering food. She is tracking her weekly income over a month to see the variability. Calculate the mean absolute deviation of her weekly incomes. How stable is Kayla's income? Joe tracks the weekly sales in his shop over the past 5 weeks. The amounts are as follows. How consistent were his sales? Last year, he said his MAD for the same time was $5,380. What might that indicate compared to this year? Christine works in public health. She is tracking a flu strain across an area. She records the total number of people infected in different areas of the state last week and has the following data for Georgia. Based off the MAD, is the number of people infected consistent across the state, or is it greatly variable? Why do you think this might be the case? Take a look and you will see a mathematical world around you filled with data. The mean absolute deviation tells us how spread out the data is in a dataset. A high MAD indicates that the values are spread out, while a low MAD indicates that the values are close together. This measure is useful for making informed decisions based on data. Remember, the ideas of low and high MAD are relative to the values in the dataset. Datasets with large values like house prices, distribution of income across countries, or even distances in space may have a MAD that is in the thousands, millions, or billions. Inherently small values like the size of bacteria, atomic structures, or even customer satisfaction on a 5-point scale may have a small MAD, but it is gigantic in relationship to the data. Therefore, it is important to keep this perspective in mind when discussing the MAD. The mean absolute deviation is a valuable tool in descriptive statistics that provides insight into the consistency and variability of data. MAD and other statistical calculations help us make informed decisions based on data and are useful for planning, managing time and resources, and setting realistic expectations.